How to build a Blackgates Sweet Pea 5-inch gauge locomotive. Part 70. Checking the fit of the first piston and rod in the cylinder and all is okay. Starting work on the second piston, showing a better method of making it from these small lumps of cast iron. This clip shows the tool post on my Smart & Brown lathe, and that is the same number that is on the cross-slide hand wheel when the diameter of 1.5 inches was reached. One down and one to go. Here I'm withdrawing the live centre, and now the piston and rod can be removed from the collet chuck. Is it going to fit? Is it going to be a good fit or a rattle fit? Well, the answer is, so far it's a really good fit. Just like a distorted story of Goldilocks and the Three Bears. Not too tight, not too slack, just right. To make doubly sure that this is correct, I'm bolting the cylinder cover to the cylinder. I'm only using a couple of bolts for this job, and once they're tightened, the fit of the piston is really good. I can pull the piston rod in and out, and it's not tight at all, but I can feel that it's firm, it's not rattling about in there. I'm making the second piston in a different way, although it does have a lot in common with the first one. Once again, I didn't turn the cast iron blank down to the finished size at this stage, and I turned it to 2 different diameters. There's a reason for this. Now I can hold it in the chuck and I have a step to press up against the jaws. This ensures that the part is accurately positioned in the chuck for the next part of the operation. Now you can see why it wasn't important when I very roughly faced across the piece of cast iron. And it still isn't important at this stage to get a good finish. This will be the inside of the piston, the part into which the rod screws. I'm going slow at the moment just to illustrate that from this very roughly machined blank you can easily obtain a good finish just by not rushing the job and turning the cross-slide hand wheel very slowly. One thing that you have to watch when you're doing a job like this is that the lathe saddle doesn't move away from the work. The saddle on my old Boxford lathe does need tightening up slightly. I temporarily nipped it up with the pinch bolt, because before that, as I wound the tool backwards towards me, it left the work 3/4 of the way down, as the entire saddle moved away from the chuck slightly. I need to remove just the right amount from this piston, so I've marked it with a felt tip pen. The thickness of the finished piston needs to be 5/8 of an inch. And what I'm doing at the moment, at a much higher speed, is turning the piston down to the mark, but I don't want to remove the mark altogether, just about halfway through should do it. At this stage I don't want to turn this piston to the finished size. I will do that when it's mounted on the piston rod and it will be in the collet chuck. This is the final cut whilst it's still in the 3-jaw chuck. You can clearly see that the felt tip pen mark hasn't disappeared altogether, which means that the piston blank is now slightly thicker than 5/8 of an inch. As I wind back and forth in this clip, you can see that the saddle has moved away from the work. Once again, I tightened the clamp bolt and this fixed the problem. This Boxford lathe is quite ancient and it does need some attention. And when I give it the attention it deserves, I will of course make a video about it. This is the final finishing cut, and it really is very close to 5/8 at this stage. Once the piston is screwed to the rod, 1 or 2 extremely fine cuts should size it to where I need it to be. The lathe started playing up for 2 reasons. One is it's very cold and it's taking more energy to rotate the lathe, and it's Sunday lunchtime when people are cooking Sunday dinners, and I think the power in this village is not what it should be. It's worth mentioning that this lathe has a 3-phase motor and I have to use a single-phase converter for it. I centre drilled the hole first and then drilled it all the way through 5/32 of an inch. Then I threaded it 2BA. I finished off the job under power using back gear and a very slow speed. With the lathe running in back gear, the pulsing of the 3-phase converter unit stopped. I think I need to move the belt on the counter shaft. I will do this in due course, but not today, it's too cold. Here I've switched the lathe into reverse and I'm unwinding the tap from the piston blank. When doing this though, I always have my hand on the tailstock and just help it along, because the drag of the tailstock on the bed could possibly give me a distorted thread. Normally I wouldn't use power to withdraw a tap from the work, but even though the heating is on in the workshop, the metal parts like chucks etc. are very cold to the touch, and the hand I used to rotate the chuck is now feeling very cold. Time now to screw the piston rod into the piston blank. This has to be very tight. The drawing shows a recess in the piston blank and a 2BA nut fitted, but I'm not going to do it that way. I'm just going to screw the piston rod all the way into the blank. Unlike in the previous episode, I'm screwing the blank onto the proper piston rod, and by applying quite a lot of pressure with the tailstock handle, it opens out the end of the piston rod and it grips the piston tightly. And in the next episode, in conjunction with the pressure applied by the tailstock live centre and the fact that I will be machining grooves in the piston, means that the piston itself will be very tight on the rod. All I have to do now is turn down the final diameter to 1.5 inches. Right at the beginning of this video you saw the number 110 written on the tool post, and really that's all I have to do. Making sure though that I do get the correct 110 on the dial and don't make the piston far too small, I checked it against the original piston diameter before I started turning. And that way I found out how many times I have to turn the cross slide handle to get the right 110. As the piston blank is only mounted on a 2BA thread on a piece of 1/4" stainless steel, I can only take fine cuts. And I'm going towards the chuck and away from the chuck because both sides of this cutting tool are very sharp. Here I'm turning the piston blank to exactly the right thickness, and because it's not supported by the live centre, I'm only taking fine cuts. And once again this shows how unimportant it was to get a good finish on the piston blank to start with, but now it's getting better. When I get right up to the piston rod, I'm just trimming off the end of it like this. A very fine final cut, and now the end of the piston is perfectly flat, and all that's left to do is to remove the sharp edges using a piece of wet to dry sandpaper. With the tool setting exactly the same, I fitted the previous piston and rod into the collet chuck and took a cut across the front of it. Unfortunately, on the outside edge of it I took too deep a cut, and this is what happens. And I was also running the lathe at too high speed. I got some chatter marks around the edge. You can see them more closely in this clip. In the next episode I will be cutting the grooves in both of the pistons. Here I'm setting the parting tool at centre height. Today I ordered some more cast iron from Blackgates Engineering, so I will be doing a special called How to Machine Pistons for Miniature Steam Locomotives. But the next episode will be all about cutting the grooves in these pistons. And that's it for now. Stay safe, stay healthy. Thanks for watching, and I hope you found it useful. Please take the time to visit my main Steam Models website and click on the section of the website that says Video Playlists. And by doing that you can find other videos that you may like to watch. And by using the playlists you can actually watch the videos back to back.